Let me probably start sharing my screen directly and jump into slides and talk about the agnostic is the only constant and how you can actually use governance in a lakehouse at scale. Because, like everyone is presenting a lot of data, a lot of new tables and a lot of new users. But the question is right now how to scale the whole stuff on access, on all the different governance aspects. And thank you very much, StarRocks, for organizing that summit and inviting me to that summit, giving me that opportunity to talk about the topic. And I would love to dive into the topic. But before, let me just mention one thing is the open source, because as you probably know, StarRocks is on open source, and what we built at Vakamo is an open source REST catalog, Lakekeeper. And the whole movement of Lakehouse based on Apache Iceberg is again driven by open source. And usually I like to run a poll to understand like how the attendance is contributing or using the open source, and the results are that a lot of people are about just to use the open source, but there are not that many who contributes to open source. And I'd like to motivate you guys to use your time to contribute to open source. And it's not just about to write code. So if you will probably tell me like, oh, I don't know how to write some in Java, in Rust, and in all the different languages, it's just taking the open source, testing the open source, and maybe writing some feedback if you found an issue, or you found the documentation is incomplete, or in a language that is not available for everyone, so you just able just to go and translate that. Or simple giving a star to a project, that is as well a contribution to open source community to foster the whole movement, because it's why we all able now to speak today, right? Been already introduced. So Viktor Kessler. If you have like any questions afterwards, you can easily reach out to me via email, LinkedIn, Slack, all the different channels. So feel free to ask me everything about Lakehouse Iceberg, and especially Lakekeeper. It's a catalog what we created. Again, it's Apache 2.0 open source catalog. You can find that on GitHub, Lakekeeper. And feel free to contribute. We're open to all the different contribution. We have right now 30 different contributors who found something what can be improved or can be added to Lakekeeper or fixed, and expecting to get even more on that one. Well, I'm pretty much like an aspect of history, and therefore I will show you a couple of history approaches about like how we actually started, where we've been, and where we're right now, so you can actually understand why we're talking about that topic. And let me start with the data evolution. So you probably, some of you, not all of you, know like in the late 90s we had that movement of data warehouse, and main technologies were like Oracle, Teradata, Netitsa, and Greenplum maybe. And it was quite interesting to use that, and it was very useful to capture all information from your ERP or some financial systems. But suddenly what happened? Internet happened, right, in 2000, and then we understood that we have a huge amount of data, and it wasn't very structured data that we can fit in a kind of like a third normal form or in some kind of schema like Snowflake or Star schema of data warehouse. And that required a new type of technology. And then we got the rise of Hadoop, Spark, Hive Metastore. And we were able to store a huge amount of data. The mid of 2010, we've got like movement of cloud, and that brought us like additional capabilities how to manage data. And then we've got rise of such system like Redshift from Amazon or Snowflake, and those systems allowed us to store a huge amount of data, because we separated storage and compute, so you could store as much as you want, and you can then analyze as much as you need, so you can provision as much of computers as you need for your specific analytics. So the guys on the other side, on big data side, they created similar stuff, and they called that data lake. And probably you're aware about the S3, Trino, Databricks, and that allowed us to go and then analyze a huge amount of data, almost infinite amount of data in petabytes area. Unfortunately, both of that system, like on the warehouse side, we couldn't go and store huge amount of data. It was quite expensive. On data lake, we had some limitations in terms of asset transaction, schema evolution, and so on and so forth. And it's why we've got a movement of a lakehouse. And one of the main players here is Apache Iceberg. So you see 2025, it's today, but the Iceberg itself started 2017. And it's been like a story and journey of Iceberg. But now it's matured a way to combine warehouse and data lake in a so-called lakehouse. And Iceberg. So let me explain the role of Iceberg and what's the improvement is here and how we can actually use Iceberg not just only for reading and writing, but for governance, governance on access, on compute, and context. Well, first of all, what you have is a write compute and read compute. And what they do, they actually go to Iceberg, and Iceberg is divided into main layers, in a meta layer and a data layer. Well, data layer is quite simple and well known. It's an object storage where you're going to store your Parquet file. You can store ORC and Avro, but usually you will find Parquet files. But meta layer is quite interesting because what we have here, we have a so-called catalog, a catalog that is well responsible to commit a transaction to tell you what the current state of your table is, and that is exactly how things are separated in Iceberg. The good part is that your write read compute will go actually to Iceberg meta layer, ask, for instance, where is the location of that table, and the catalog will tell, okay, if you want to read the table, you need to go to location S3 colon slash slash and so on. And then the write and read compute will go directly to object storage. And that is some separation that will avoid the whole bottleneck, what you know from a well, classical monolithical database approach from a data warehouse. And the good part is that your data is not locked to anything because you can use like Spark and Flink and Python, and you can use something like some proprietary classical Snowflake, but you can use a StarRocks, and StarRocks is quite interesting in that space because the whole innovation, what I saw from my side in the last couple of months on a StarRocks side was very interesting towards the Lakehouse. And then the Lakehouse architecture is probably well known. So we have the producers and consumers, the producers writing, the consumers reading. And then what you will probably need is a write compute and read compute, which I already mentioned. And you will write to storage as a Parquet file, Iceberg. And the main thing is a catalog that will allow you to bring the whole idea of Lakehouse to life. Again, some evolution on the catalogs probably interesting to see. So as I said, we started with Iceberg in 2017, and we had a couple of different ways of to manage the meta layer. We had Hadoop catalog, JDBC, Hive, Medesto, Nessie, and I call it all like a before REST era where we had no specification. As you probably know, Iceberg has have 4 different specifications: a table spec, a view spec, payment pattern spec, and REST catalog specification. And the REST catalog made it actually easy for every catalog, for every client like StarRocks to go and read the data because it was just standardized. So a REST catalog specification is a standard, and it's why we call now like the after REST era. And on after REST era, I observed some kind of evolution. So we started from a catalog. Now we have that metadata JSON file that is managed by a catalog, and that's something how we want to try to have a table state, a table life cycle. Then we add some metastore features like fine-grained access control, and that's where we're starting with the governance on the catalog side. And we said, okay, now we want to use the REST catalog just to say who is able to access that namespace, that warehouse, that table. And the next phase, exactly where we are located right now, when I talk to customers, to companies, is that, well, actually, it's not just a metastore. It's now some sort of a control plane for data in AI, where we will control who is going to access my data, I will control what type of context we will provide. I will control what is the computational governance in terms of having a way to see what is happening with my pipelines. And let me introduce Lakekeeper. It's one of the so-called control planes that has exactly those three main components: the table management and maintenance, fine-grained access control, and compute and context governance. The interesting part of the catalog, because it follows the REST specification, you can actually use that very agnostically. You're not tied to anything, and you can pick exactly the technology what you need for your use case. And if you look at the StarRocks, it's very good in a very fast type of analytics. So if you want to just go and then do a real-time analytics, that's where StarRocks is very good at. If you want to write data, you will probably use something like Spark. If you're on streaming, you can use Kafka in a small data DuckDB. And the cool part is, if you, let's say you're on some proprietary technology like Snowflake, you can easily move the whole workload through Iceberg to StarRocks. And same on your storage. You're not locked anymore to a single storage. You can go and use that different storages. Very brief introduction of Lakekeeper, written in Rust. And we can use that with all different hyperscalers. It can be used on-prem. We support vendor credentials, remote signing, natively running in Kubernetes, single UI, single binary. We can provide UI as well. And it's modular and extendable, which means you can actually go and rewrite some part of Lakekeeper for your specific security and governance aspects. And we'll touch that in a second. And one of the main thing is about the maintenance. It's what we provide with Lakekeeper Plus. So everything about the expire snapshots and compaction and so on. Let me touch on the fine-grained access control. So what we have our control plane that controls access, for instance, to your tables. It runs on your Kubernetes, and then you have a general compute. It can be Spark. And in that case, your Spark application will use the machine flow, so it's using client ID, client secret, and it's all fine. But then suddenly we have a multi-user system, like for instance, StarRocks, where you have hundred of users, and you want to just actually be sure that user A can read a customer table and user B cannot read the customer table. What we developed in Lakekeeper is the extension on our authorizer trait that you can actually add all the different authorization system. And our implementation is based on OpenFGA. And for some systems, we developed the so-called OPA bridge that allows you actually to control who is accessing what. But the new development inside of our Apache Iceberg community is the so-called Iceberg Out Manager. That's a proposal that is again developed and adopted by StarRocks, and I hope that in version 4 is going to be like part of the StarRocks as well, and that will actually make the whole system way more simpler for you. So in that situation, you will have StarRocks able to access through Lakekeeper on your tables, and then StarRocks is able actually to be a trusted compute that can understand who is running that query, and the trusted compute will actually make a decision to allow to run query or to block that query. Let's just move on to the change events, because we are on a governance and we're trying to scale the governance, and there are different aspects to governance, not just about the access governance, but sometimes you just want to know like what is happening on your system. And again, so you have your compute and you want to run the alter table. And usually it's quite interesting information because you have a metadata change. It's not just a change of a table, so you rename the field. What we can do in Lakekeeper, we can push that event to a queue, to your Kafka or NUTS queue, and you can build a third-party systems that will react on that one. And it's quite interesting mechanism because it allows us to build a so-called computational governance. So how does it work? Again, Lakekeeper control plane, we have a user, let's say a data engineer, and that user uses dbt to do some changes with the data. And then we have an analyst from sales who uses StarRocks to run analytics on top of that Apache Iceberg tables. And what sometimes is happening that data engineer needs to run some changes, right? So understand, okay, I need to go and drop a field or rename a field. Unfortunate thing in huge organization, data engineers and analysts, they don't know each other, and that relationship is not documented or enforced, which means in that type of operation on alter table, the table can be broken and business will be interrupted, which has like a direct impact on some very business critical decisions. And that's something what you don't want to have. So what we introducing in Lakekeeper is some sort of idea of a data contract engine where you can define computational SLOs. Like one of them is stable schema. And that stable schema is actually the way that Lakekeeper will make a check again, not just on a fine-grained access control, but on that SLO. And the alter table will get a conflict. So the data engineer will see, oh, I am not able to run that operation alter table because I have a contract on that table that prohibits me to make that breaking change because there's a business critical process. And that's the idea of a computational governance, what we introduce in Lakekeeper. There are way more different SLOs what you can put on that contract, but that's just the whole idea of how to scale the governance just beyond the fine-grained access control. So 2 minutes left, and I would love just to give you some outlook what we're building with Lakekeeper and with the whole idea how to scale the governance, how to remain agnostic, because it's not just about to integrate you in a single vertical stack, but you wanna stay agnostic in terms of to avoid locking. And one of the things is that we want to have a contextual governance. So you build your RAC application, and that RAC application, let's assume there's a question about the forecast of revenue in the next year. And it depends who is asking that question. If it's a CEO, so RAC application can deliver that answer. But if it's not a CEO, so someone who shouldn't know that type of information, so how are you going to manage that contextual governance? And that's the idea of Lakekeeper, where we can actually help you to apply that type of a policy. The next thing is the catalog federation. So what we believe is that at the end of the day, a huge organization will end up with multiple catalogs implementations. Same what you have right now. So you have maybe DuckDB, you have StarRocks for different type of application and use cases, and same here. And that's exactly where Lakekeeper can help you to federate all that catalog. We evaluating broader scope on volumes and table formats. So if you want to just have governance on whole lake, not just on the structured information, that's something what we will provide as well. And the most interesting part is from a business side is how to share and collaborate. And that's the way of where data contracts will bring even more control for you. That's it from my side. I would say I've just used my 20 minutes, and I hope you like the content about how to remain agnostic, how to build the governance, and how to scale the governance on the Lakehouse. If you like Lakekeeper, please feel free to give us a star, and I hope we've got some questions here.
All right, thank you for that talk, Viktor. Opening it up now to any questions you may have. Also, if you haven't joined the Slack, feel free to scan that code as well on the left. Just head on over to the session tab for Q&A. Viktor would be happy to take some questions.
Yeah, I see there's a question about why Lakekeeper, why not Ice Bucket. Yeah, interesting, Anton. Let's discuss that. But I think the first idea was because we focused on governance, and the idea that someone needs to kind of be a keeper of a lake and know who will add what type of information in a Lakekeeper, what is going to access that lake. That came in our minds to have a Lakekeeper name.
So any other questions, feel free. I have a question, Viktor. I guess maybe for those who are interested, what does the roadmap look like for Lakekeeper, say 3 months, 6 months, going into the new year, if you could share?
Yeah, absolutely. That's a great question. Well, the first thing what we will release is the Iceberg v3 support. That's something what is probably very essential, and that well, let's see, in 2-4 weeks is going to be available. The second thing is the first data contract. So you will be able to go to a table and say, there is a contract, please don't break it. And the third and last thing is we will provide this SaaS solution for Lakekeeper. Because right now, if you want to use Lakekeeper, you eventually need to go and then install that on your Kubernetes, for instance, through Helm chart. And now we get like more and more questions. Is there like a SaaS, a easier version to use it? So those three things are in making.
Awesome.
And maybe just for everyone who is in Europe, there is an upcoming event, StarRocks Vakamo Lakekeeper in Hamburg on November 13th, just to do some advertising for upcoming meetup.
Great. It looks like we have a few other questions coming in. Anton asks, any other formats?
Yeah, so as of now, it's Iceberg only, but we open to a conversation, and I see probably something around the formats for AI embeddings, non-structural data. Yes, that's something what we would love to add. Yeah. So then I see the question about how to scale. Yeah, that's quite interesting question. Well, Lakekeeper itself is stateless, so we don't have state inside of Lakekeeper, and you can easily scale that on your Kubernetes. It's super easy. The only one thing what you need to think of is the Postgres, where we're going to store this state of Lakekeeper. And there are very good examples how you can scale Postgres. So it's not something what you need to reinvent. You just follow some booking.com examples, and I don't know. So what's your version on in future of built-in access controls in compute engines like Starburst? Bring your own control Apache Ranger control. Well, what I know, like on Starburst, they will probably use the open policy agent bridge today, but as StarRocks, for instance, you will use the new proposal. I hope that's going to be through in Apache Iceberg community without manager, and that's something what StarRocks is going to deploy as well. The thing is that your controls, as you write correctly, should be outside of catalog or query engine, and Apache Ranger is probably one of good examples from past. Now we look at the open policy agent. But if happy to get a contribution for Apache Ranger if you want to. It's an Andrea, yeah. So then, is there any plans to support other formats? Yeah, well, Parquet, we do support Parquet or C through Iceberg, but I don't know, like you're thinking probably about like to replace Hive Metastore. Interesting idea. We had that somewhere as well, but so far no one really asked that. I think that the whole industry tries to move to Apache Iceberg or something like that. So at least a lot of companies trying to move to that format, and there are the other pains using like Parquet or CSV, right? So and Iceberg solves that. So maybe here the last one from Igor. So if you have bunch of tables, would you like to keep an eye on example, provide a catalog for external users like Lakekeeper? Would you like to? Yeah, well, it is possible to do. I don't understand correctly the question, maybe, but yes, you can use the and provide the external access as well. Yeah, that's possible. Yeah. Well, and from Eugene, that's interesting. Data mesh manager. I don't know. We might think about to integrate that as well with data contracts. The only one thing is on Lakekeeper side is that the data contract what we will provide is preventive, right? So because we in the control of that operation, so alter table or whatever you're gonna do, we as Lakekeeper we controlling that, so you're not able to break it. That's the whole idea, and we don't want to be like a post-mortem engine. that if you break something and then the lamp will go on, that's like a different approach on our side. Okay.
All right, cool. We are a little bit over time, but thank you guys for those questions. Thank you, Viktor, for your session. As I mentioned again on the screen, we have the QR code to the StarRocks community Slack if you haven't joined yet. Otherwise, thank you for attending this session. We'll close it now. Thanks, guys.
Perfect. Thank you. Thank you. Bye-bye.